it is best to start with the definition of proportions of sides with similar triangles. That's the rule that we learned about proportions. Remember, when you have a 30, 60, 90 triangle, we set them up to look exactly the same, and they're proportionate, right? And then we say this side is to this side, as that side is to that side, right? We're going to do the same thing. We're going to say this red side. I'm going to try this a little different this period, see if it comes out better. This red side, right? Now when we're talking D, E, F, D, E, F. See how that goes? Sorry, let me do that in black. D, E, F. So what's happening is we're going in this direction, right? And we're coming in that direction, right? Okay? Oh, look at that red. Okay, and then so this DE is going to be proportionate to a red side on this one. Now, which side do you think it is?
Wait,
and
on
so
the side?
to this guy. So DE will be proportionate to RS.
I think it would be.
Right?
So it's RS.
So this one would be your red side, your proportionate side, right? So what we're going to do is we're going to say 35 is to 98, right? And then we'll do a purple side, okay? So this is the long side. So this purple side is, what is this? ST, right? So the ST would be to the DEF, right? So ST is to EF. Okay? And that means then 35 is the small guy, right? Small triangle. So on this side we're going to put the 5x plus 15, right? Because that's the small triangle, this little guy. The big triangle, that's on that side. And that's going to be 98 to 182. Right? So, the small triangle's red side to the big triangle's red side. Right? Compared to the small triangle's purple side to the big triangle's purple side. Does that make sense?
Wait, where do you get big triangle, small triangle?
The big
Well, this one's smaller than that one.
Oh.
Right? 35 is smaller than 98. Does that make sense? Now, let's just, for fun, just for fun, let's redraw this triangle like this. Remember how we like to draw the triangle on the side? The 30, 60, 90? And when we did that, then this red side right here, this red side, right? From D to E. Okay? From D to E is right there. Does that make sense?
Wait, what did you do?
So when I redrew this, okay? So that it looks just like this one, right? DE is the RS, right? Okay? So 35 is to 98. Okay? And then the purple side, right? EF, right? That's this purple side, is to this purple side. Does that make sense?
182.
So 182 to 5x plus 15, right? So we're saying from this small triangle to the 182. Okay? So 35 to 98, 35 to 98, and 5x plus 15 to 182. Okay?
Is that it?
Well, that's a start. That's a big start. That is the definition of,
Special triangles.
no, sorry, I said it earlier. The definition of proportionate sides of similar triangles. Okay? The definition of proportionate sides of similar triangles. Okay? Now, it's basically the definition of similar triangles, but we want to use that word proportion. Okay? That's a really important word for the state test, right? So, it's something that we want to get used to writing. Okay, so the definition of proportionate sides of similar triangles. Okay? Now, there's something I learned. Wow, that was I just went back to 12 years old, right? My voice cracked. There's something I learned when I was in college, right? And I was sitting there, I was all stressed out on this test because it was my midterm. It was the first midterm when I was actually doing well. Because I had flunked out of college twice. So I'm doing good. I got 2 A's last quarter. I came in this new professor's calculus class. I'm working on this problem. And I'm like, oh, dang it. And I got something just like this on the test. And I'm just like, how do I do this? How do I do this? What was that rule? And I was trying to remember the rule, you know, the cross multiply rule. And I was like, oh my God. Can't remember, I don't know what I'm going to do. And if I only had 3 problems on that test, if I don't get this one problem right, I'm going to fail. And if I fail again, this will be the 3rd time I flunked out of college. I'm not going to let that happen, right? So I said, okay, slow it down. Okay, and I thought to myself, I'm just kidding. I thought to myself, I said, use what you know to figure out what you don't know, right? And I knew this. I knew that 1/2 was equal to 3/6, right? And I said, okay, so what if I flip those? Is 2 over 1 equal to 6 over 3?
Yeah.
Okay? And then I said, okay, if that's true, 4 over 8, would it also be true 8 over 4?
Yeah.
So is it always true if I flip both sides? And I was like, if it works 3 times, it's usually true. That's the way we prove things in math. We want to prove at least 3 times. Twice could be a fluke. 3 times, usually not a fluke. Sometimes it is a fluke, and it just happened. But most of the time in math, you do something, you do a pattern 3 times, and now you got a pattern, right? So I'm like, okay, I think I can do this. So at least I felt better about the problem, right? And so I said, I'm going to flip this problem.
So 35 is, now it's 5x plus 15
Wait, did we
equals
skip a
128,
couple,
82?
Did we skip a couple of problems?
So you just flip the purple to red?
Yeah, we're on 14.
Or not problems, like on the side where you write what you do?
No. We're just getting to the next step.
So
Okay?
you put
So
the
we
purples
only
on
did
top?
one.
Yes, I'm going to put the purples on top. So I want to get this X on top. And it's so much easier to deal with when your X is on top. Okay? And put the 35 underneath. So I'm going to put this, but what I do to one side, I have to do to the other side. Okay? And so what I call this is the definition of inverse. Okay? The inverse property. And what the inverse property tells me is that if I take the inverse of one, it'll equal the inverse of the other. Okay? And we have a thing in Algebra 2 where we learn that the inverse of a function, right, is equal to its inverse. So the function, if you take the inverse of a function and you take the inverse again, then that will actually equal the original function, right? So all you're doing is flipping something and flipping it again.
Wait, so inverse is just like flipping?
Yes, the inverse is just flipping that fraction.
I'm gonna use a different color.
Sure. Okay, so then, once I get to there, now I'm like, how do I get, and this is really important, and you might think, why the hell am I going to do this, right? And it's not, it's really important, because when we get into sine, cosine, tangent, oh my goodness, you're going to have sine of 32 over 5 is equal to 6 over x, right? And so now you want to be able to flip those things, you know? Or it might be the sine of 32 over 5 is equal to tangent over x. Tangent 50 over x or something, right? So you want to be able to flip those things. So you get x by itself, then you just throw that tangent on the other side, and it's really easy, okay? Otherwise, you're cross multiplying, and then you're dividing. It's just a lot of steps. We don't need that many steps,
So it's
okay?
like x plus 15 equals 180.
So now I'm going to multiply this by 35. And I'm going to multiply this by 35.
That's 'cause
Now these are just big numbers, right? Now here's the thing that I learned a long time ago, right? And that is, when I start to teach factoring, I learned to break up these numbers into factors. Instead of multiplying this again, right? And getting a big number, and then trying to divide it by 98, which can be difficult, okay? What I like to do is break down the numbers. So first of all, I have 5x plus 15 is equal to 182 times 35, okay? And what that is multiplication property of equality, right? Okay? But what I'm going to do next, okay? Plus that's over 98, right? What I'm going to do next is I want to try to break this down, because I can't subtract 15 from that number yet, right? So I want to try to simplify this problem, okay? So let's take a look at this problem. 182 and 35,
Wait,
right?
can you just get rid of that 35 right there?
Yeah.
I can't just get rid of it. Well, I could multiply
I'm
it.
talking about up there.
Yeah, it's because he cuts off the.
Yeah, these canceled. Those two 30, that's why I multiplied by 35. I did the opposite what was happening to the x, right? So that's your sad math, right? So we're gonna do the opposite,
So what-
parentheses, right?
Would I write that?
Yeah, the 35, 35, right? Yeah.
Would I write sad math? Okay, so
You can. Now, we did that in algebra, but for you guys, sad math means subtraction, addition, multiplication, division, property of equality, right? And so that's why we did multiplication, property of equality to get to here. Okay? You with me, Noah? You got it? Okay. Now, I'm going to break these up. Isn't 35 7 times 5? Right? And I want to take something out of here, because this is more than just 7s and 5s, right? There's not even a 5 in 98, is there? So I'm going to break up this 82. This 182. So the first thing I'm going to break it up with is a 2. So I think I'll take this 182 and I'll break it down. 2. 2 times 91, right? Okay? And then what else goes into 91? I can't think of much. Can you? Right? This is not fun. It's an ugly problem.
Like a number.
91. 2, 3, no. 5, no. 7? Yeah, 7 does. Okay. There we go. So 7 goes into 91 how many times? And the reason I knew 7 did is I said 7 goes into 9 once with 2 left over.
Do you
Right?
write this down?
So that, yeah, definitely write this down.
wait, is that a
So this goes in 3 times, right? So 7 goes into 9 once with 2 left over. 7 goes into 21 3 times. Okay? So 91, that's why it's such a nasty number, is it's 2 primes. So what's really happening up here is I've got 2 times 7 times 3. All over times 7 times 5. Okay? All over, what's 98? So let's break 98 down. 98 divided by 2. 49. 7. 7. 7. 1. So, all over 2 times 7 times 7. Okay? Now, do you see why I wrote it out this way?
Maybe.
Now, you could have just said, multiply this and divide by 98. You would have came up with a number, right? In your calculator. But what if you don't have a calculator? right? Then you have to do long division. And you don't need to do long division. Because look, the 2's cancel. The 7's cancel. And the 7's cancel. And later on, when you're doing stuff like statistics, probability, this is going to become a really, really powerful trick of breaking these things up into their factors, right? And getting rid of the factors that are the same on the top and the bottom.
Is there any specific name for what you're doing here, Claire?
This is called prime factorization.
So will you write that down?
Yeah, you could actually, right here, just say definition of prime factorization.
Wait, what's that 2 on the top left of the 182?
That's a better two.
The what?
The 2 on the top left.
Divide.
This one? Oh, I was dividing it by 2, but then I decided I'd come over here and do it. Is that better? Okay? So, I did all the work over here, then I can come over here and just go, bingo, bango, I got, what's left? 13 times 5, right? So what is 13 times 5? So what's 5 times 10? 50 plus 5 times 3, 15. What is 15 plus 50? 65. So I have 5x plus 15 equals 65. Okay? You see where that came from? And all that is simplify. That's all we did. We simplified it. Wasn't simple, but we simplified it. Big numbers. Nasty fraction. But now, not a fraction. Right? And so now what am I going to do with that 15? So 5x plus 15, SAT map says subtraction addition first, right? So I'm going to subtract 15. Subtract 15, and I get 5x equals 50, right? Subtraction property of equality. Then what do I do? Divide by 5. And I get x is equal to 10. Alright? Division property of equality. Okay? So all of this prime factorization went to right here, which went to right here. So it was all part of your simplification. Okay? So, like I said, some people are just going to throw this in a calculator and figure it out and go, oh, 65. But some people are going to take the time, right, to do it this way. It's a lot easier. I mean, I could have multiplied 182 by 35 and then divided it long division with 98. But to me, it's a lot of